Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll use concepts of vectors to solve this problem. As per the problem, square ABCD is drawn with the diagonals intersecting at E. In part A, we have to state four pairs of vectors that are equivalent. Let's start with part A. Equivalent vectors are vectors that are equal to each other. This is a very important concept we need to understand and memorize. Vectors are equal to each other if they have the same magnitude and direction. So we have to state four pairs of vectors that are equal to each other. We have to analyze the given diagram for square ABCD to find the four pairs of equal vectors. In a square, all sides have equal length and opposite sides are parallel to each other. And diagonals of a square are perpendicular to each other and bisect each other. That means they divide each other into two equal parts. So let's use all of this information to find four pairs of vectors that are equal to each other. In the given square, the length of side AD is equal to the length of side BC, and these two sides are parallel to each other. Side AD is represented by vector AD. Vector AD goes from point A to point D. Side BC can be represented by vector BC. Since both vectors have the same direction and the same magnitude, these vectors are equal to each other. So the first pair is vector AD is equal to vector BC. In this square, side AB is equal in length to side DC, and these two sides are parallel to each other. Side AB is represented by vector AB, side DC is represented by vector DC. Since these two vectors have the same magnitude and same direction, these two vectors are equal to each other. As I mentioned earlier, diagonals of a square bisect each other. That means the diagonals divide each other into two equal parts. Therefore, length of line segment AE is equal to the length of line segment EC. Line segment AE is represented by vector AE and line segment EC is represented by vector EC. Since these two vectors have the same magnitude and same direction, vector AE is equal to vector EC. Now we can identify the fourth pair of equal vectors. For that we can analyze diagonal DB. Diagonal DB is divided into two equal parts by point E. Length of line segment DE is equal to length of line segment EB. Line segment DE is represented by vector DE. Line segment EB is represented by vector EB. Since these two vectors have the same magnitude and same direction, therefore vector DE is equal to vector EB. So these are four pairs of vectors that are equivalent. Now we can answer part B. State four pairs of opposite vectors. Opposite vectors are vectors that have the same magnitude and are parallel to each other but have opposite directions. So let's start by analyzing vectors that represent the sides of the square. As we discussed earlier, vector AD is equal to vector BC because they have the same magnitude and same direction. Vector BC is opposite to vector CB because vector BC starts at point B and ends at point C, and vector CB starts at point C and ends at point B. Therefore, vector AD is opposite to vector CB. This is a very important concept we need to understand and memorize. Now we can identify the next pair of opposite vectors. As we discussed earlier, vector AB is equal to vector DC. Vector DC is opposite to vector CD. That means another pair of opposite vectors are AB and CD. As we analyzed in part A, vector AE is equal to vector EC. Therefore, vector AE is opposite to vector CE because they have the same magnitude but have opposite directions. Similarly, vector DE is opposite to vector BE because they have the same magnitude but opposite directions. So we are done with part B. Now we can answer part C. State two pairs of vectors whose magnitudes are equal but whose directions are perpendicular to each other. As per the properties of a square, all sides have same length and adjacent sides are perpendicular to each other. Therefore, vectors that represent adjacent sides of a square have the same magnitude and are perpendicular to each other. Therefore, vector AB and vector AD have the same magnitude and are perpendicular to each other. Similarly, vector AD and vector DC have the same magnitude and are perpendicular to each other. So these are two pairs of vectors whose magnitudes are equal and are perpendicular to each other. So we are done with part C. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.